Kia ora all. Here is question 2 of the 2024 TGC Derived Grade Level 2 Chemistry exam, and this is the chemical reactivity paper. So this is the equilibrium question by the looks of it. The Haber process is used to produce ammonia gas from nitrogen and hydrogen. Equilibrium constant expression Kc is this. Write an equilibrium equation. Okay, so it's given you two ways to write this equation, words and a Kc. So of course these are my products and these are my reactants. So I'm going to have N2. It does tell me what the states are here. They're all gaseous, so I'm going to put that in. Plus the key point for our reactants is that I'm going to have 3H2 gas, and it's an equilibrium, so I use my equilibrium arrows, and then I'm going to have NH3 gas, and I'm going to have 2 moles of that. Calculation question. You're given a Kc, and you need to calculate the ammonia given the nitrogen and the hydrogen. So the first thing we're going to do is we're going to use this Kc expression. I'm going to write it down here. NH3 squared over N2 times H2 cubed. Okay, so that's the one we're looking for. Calculate the concentration of ammonia, so I'm going to call that X. I'm going to put my 640 into here. And I'm going to put my X into here. And my nitrogen is 0.0304. So 0.0304 times my hydrogen 0.0912, and don't forget to cube that one. So I'm going to do all this bottom line first. So 640 is going to be x squared. I'm going to get my calculator. 0.0912 squared. And then, sorry, not squared. Let's do that again. 0.0912 cubed. And then I'm going to multiply that by 0.0304, and that gives me 2.305 times 10 to the power of negative 5. So over 2.30599 times 10 to the negative 5. Okay, so now I'm going to multiply this up here. So x squared is going to equal 640 times 2.30599 times 10 to the negative 5. So I've still got that in my calculator, so I'm going to multiply that by 640. And that gives me x squared equals 0.014758, blah, blah, blah. So x is going to equal the square root of 0.014758. Still got that in my calculator, so I'm going to go square root answer equals, and so my answer is 0.121. Okay, I'm just going to put that down here. Answer equals 0.121. It's a concentration, so I'm going to put moles per litre, and I'm going to just make that really obvious that that's my answer, and I'm going to make sure I've got 3 significant figures. Right, this one here, identify and explain the effect on Kc in the equilibrium in A1, so this is the one we've been working with up here, when the concentration of nitrogen gas is increased. So I'm just going to do my general statement here. If the concentration of N2 is increased, the system responds to decrease the concentration of nitrogen by moving. Now, so if I want to decrease the concentration of nitrogen, I've got to move away from it. So it's going to move to the right, This is a trick question though, because if I start by increasing this, and then I decrease it, but it's not going to decrease all the way, decrease this and increase this, the net of these will give the same Kc. So if you don't really like that maths, then the best thing to do is remember that only one thing affects Kc, and that is temperature. And this helps us remember that because we always state the Kc at a specific temperature. We would only do that, thank you Mr. Motorbike, we'd only do that if the temperature mattered. That is the only thing that affects the Kc. So, back to our question. We've used Le Chatelier's principle. If the concentration of nitrogen is increased, the system responds to decrease the concentration of nitrogen by moving to the right. However, this returns the system to equilibrium, and therefore there is no change in Kc. Right, and in this case I can say it would remain at 640. Right, that was a bit of a trick. Hope you got that one. If you didn't, get it next time. Okay, the standard enthalpy change for the production of ammonia is negative 92 kilojoules per mole. So elaborate on how this would be affected when the temperature is increased. Okay, so I'm just going to write this back in here. Oops, sorry, H2 goes to 2NH3. Okay, so this is temperature, so it is going to change the Kc. So if we increase the temperature, right, we've got to know what this tells us. It's negative 92, so that's exothermic, and exothermic will release heat. So heat is a product. Right, so if the temperature is increased, the system responds to decrease the temperature by moving in the endothermic direction to absorb heat. In this reaction, delta H is negative, so the forward reaction is exo. Therefore, the system shifts left. In shifting left, we make more of the reactants, therefore more N2 and 3, well, actually we don't write 3H2, more N2 and H2 are produced, and the concentration of NH3 decreases because we're moving away from the NH3, and as the Kc equals products over reactants, if our products are decreasing and our reactants are increasing, that is going to decrease our Kc. It's quite a tricky one, that one actually. Possibly needed a bit more room too, so you might have needed to go into the back page. Hopefully you're not writing too much more than what I'm writing, because otherwise you won't have enough time. Right, let's carry on. The first step in the production of nitric acid, so this is a new reaction now, reaction of ammonia with oxygen to produce nitrogen oxides. It's shown here. Right, so we're looking at how the yield of nitric oxide is affected when the equilibrium system undergoes the following changes. Right, oxygen gas is added, so that's going to increase the concentration of oxygen gas. We're adding more. So that's our change. Therefore, the system will respond to decrease the concentration of oxygen. Looking at our equilibrium, if we go to the left, we're going to make more oxygen, so we must be going to the right. Therefore, the system shifts to the right to decrease concentration of oxygen, and we're looking at what's going to happen to this. If it's shifting right, it's going to make more of this, and in doing so the concentration of NO will increase. That's really all you have to write. And our last one in question 2 is about the volume of the reaction vessel. So we know that if we change the volume, that's going to change the pressure. If we decrease the volume, we're going to increase the pressure. So that's where we're going to start. Decreasing the volume increases the pressure. So the system responds to decrease pressure by moving in the direction with, this is important, fewer moles of gas particles. So remember, it's our gas particles that produces pressure. Think of blowing up a balloon. You put more gas in the balloon, the pressure of the balloon increases. Right, so what's going to happen? Remember, we're going back to, we have to talk about the yield of nitric oxide. So we're going to say, on the left-hand side, we've got 4 plus 5 is 9 moles of gas. And on the right-hand side, we've got 10 moles of gas. So we need to move in the direction with fewer moles of gas. That's going to be towards the left. The left-hand side has 9 moles of gas. The right-hand side has 10 moles of gas. Therefore, the system shifts left to decrease the pressure. In doing so, the concentration of nitrogen oxide, right? So if we're shifting left for this one, we're shifting away from the nitrogen oxide. So it's going to decrease. Whoop, there we go. Decreases. There we go. All right, I hope that one was okay, and I'll be back with number 3 in just a mo.